Well, hi there, boys and girls. Today we're going to talk about solving right triangles, and we're going to head into working some word problems. We'll deal with some definitions of angle and depression and elevation. We're going to get started right now talking about what solving a triangle means. Solving a triangle means find all the missing sides and angles. Find all missing pieces. So let's take a look at this first example. I am given, we're going to use this picture over here, and I'm just going to grab a hold of another one and pull it out over here so I can label it. I am given that we're going to put angle A here, angle B here, and angle C here. And that just reminded me of something that I need to talk to you guys about this. We are going to label angles with capital letters, and the sides, by definition, which means this should be your convention as well, the sides will be little or lowercase letters, and they will be directly across from their angles. So side length A, or little a, should be directly across from angle A. Side length B should be directly across from angle B, and side length C, make sure that's capital, should be directly across from angle C. So make sure you maybe write that down too, that the angles are across from their sides. So this is what we're going to have here, and I'm going to erase those and label what I have. So I've got measure of angle B is 38. I don't need to erase that. I know that B is 5, and I'm going to find the missing pieces. Now we can use some very basic geometry to find one missing piece. It was given to me that angle B was 38 degrees, which means I can find angle A. I know that this box means 90 degrees. 90 degrees plus 38 degrees is how many degrees we have in this triangle so far. And I think Mr. Monahan is being my calculator over here. That means that's 128 degrees taken up so far. And of course, if we subtract that from 180, we should get 52, and the calculator agrees with me. So basic geometry tells me that the measure of angle A would be 52 degrees. And I'll write it in here, but I'm going to write it out to the side as well. Now, what am I missing? Well, I have three angles labeled. I have one side labeled. I need to find a missing side length, actually two of them. I'm going to find side length A first. That's just what I choose to do. So I'm going to ask myself, what do I know? Well, I know angle B, I know angle A. You can choose either one of these acute angles. Since I was given the measure of angle B, I'm going to start with that. I'm going to say, I know angle B. And then I'm going to ask myself, what side length do you know from that angle B? From this reference angle, what side length do you know? My brain should tell me, Mr. G, you know the opposite side from the angle. The opposite from your reference angle. So I know the opposite side. And then I'm going to ask myself, what side length would you like to find? Well, I'd like to find A. Then you're going to have to answer, well, is that the adjacent side, is that the opposite side, or the hypotenuse side? So I know from my reference angle, I know the opposite side. And I am looking for the adjacent side. I know O, and I'm looking for A. From SOHCAHTOA, which sine, cosine, or tangent, which trig function deals with O and A? So we'll let this be like Blue's Clues. You guys saying it out there? Which one is it? That's right, it's tangent. Very good. So I'm going to have a tangent statement. The tangent statement would be, or equation, the tangent of 38 degrees must be equal to the opposite side divided by the adjacent side. At this point, I'm going to put a 1 underneath the tangent of 38 degrees, and we are going to do something that you should be very, very used to, and that's cross multiplication. So I'm going to multiply both sides, cross multiply, and I will get that A times the tangent of 38 degrees is equal to 5. So A equals 5 divided by the tangent of 38 degrees. And Mr. Monahan said this several times yesterday. I remember all day and all night. We're going to round to 3 decimal places, and Mr. Monahan has done this for me, and I'm going to truncate like he did yesterday to 6.399. And I like that he truncated that because rounding sometimes gets funny. It was actually 6.3997, and in this instance, if you truncate, you don't have to worry about, well, the 7 rounds the 9 up and that rounds this up, and it sort of gets messy. So we're just going to truncate this, and we're going to say that side length A is 6.399. So side length A is 6.399, and then I'm going to do one more side length, and then Mr. Monahan is going to hop in and do number 2 for you. I'm going to erase some stuff here, and I hope I'm not erasing too quickly on you. Hopefully I'm going slow enough. Okay, I would recommend that you not use 6.399 in any further calculations. You could go ahead and use Pythagorean Theorem to find side length C, and I would accept that. However, so you can see this process, I'm going to set up another trig ratio to find side length C with my givens. My givens, I'm assuming, weren't rounded, so I'm not going to use this rounded answer in any more calculations. I'm not saying you can't, and I'm going to say this again. If you use Pythagorean Theorem with these two side lengths to find the hypotenuse, I will accept that. All right, so let's go back to what I know. I know the measure of angle B. I know opposite side 5. Let's find C. So I know opposite, C's hypotenuse. Which trig function deals with opposite and hypotenuse? Hello? Yes, that's right. It's sine. So I'm going to write the relationship. The sine of 38 degrees must be equal to 5 over side length C. I'm going to drop a 1 underneath the sine of 38, and we're going to cross multiply. C times the sine of 38 degrees equals 5. So side length C will be 5 divided by the sine of 38, which is 8.121. So let's go see if I have solved the triangle. C is 8.121. I had 3 missing pieces, missing angle, 2 missing sides. Mr. Monahan, do you think I got it there?
Yep.
All right, so I'm going to turn this over to Mr. Monahan, and he's going to work example 2.
Okay, guys. How are you guys doing today? So, once Mr. G erases for me.
You got it.
Thank you very kindly. Grab a... Ooh.
Those are cool pens.
See, I'll grab black. So once again, I'm going to draw my picture, which is right here. Okay. And all in math, we always like to draw our pictures. Okay, so once again, we're going to go with our labeling. So this is big A for angle A, which would make the opposite side length of 4. Then we're going to go B. Opposite of B is little b, and then C, our right angle, and opposite of that would be 15. Now, as we notice, I do not have any of my degree measures outside of the 90, which is given, because these questions will always be right triangles. So, but Mr. G just said one of the things that we will be able to use, which would be Pythagorean Theorem, which is a squared plus b squared is equal to c squared. Now you're going to realize that I've written all of these in lowercase because they deal with side lengths and not the angles. So I'm going to manipulate this to be c squared, let's see here, minus, or c squared, c squared minus a squared is equal to b squared. I'll take the square root of both sides of everything, and I end up getting the square root of 209 is what b is. So I'm going to go ahead and erase my b, and I keep on wanting to use those cool pens.
Those are cool pens.
And this side length now is 209. Now I could have written that as a decimal and used 3 decimal places, but I like the square root. It's a nice, pretty number. Now, I'm going to erase. And now I need to find my angle measures, because I have my 3 pieces of information, but I need to figure out what angles A and B are. So we're going to start with angle A, and I have all 3 pieces of information, so I could theoretically use any of my 3, or 6 really, any of my 3 trig identities. But why don't we go with Mr. G's, oh, I've got an H. Let's go with Mr. G's idea and just use our given pieces of information. So 4 and 15. So when I look at when I'm looking at solving for A, I realize that 4 and 15 are my opposite and my hypotenuse. So I have opposite and hypotenuse, that means I need to use the sine. So I'm going to ask myself the sine of what angle is 4 over 15. And in last lesson we learned that we're going to do this is an arc sine problem. So we're going to type in sine to the negative 1 of 4 over 15. And my calculator gives me 15.466. So that means the degree measure of angle A is 15.466. Now, I could use the fact that the addition of the 3 angles inside the triangle adds up to be 180. So I have 90 plus 15.466 plus x is equal to 180. Using some algebra, I can see that the fact that x is equal to 74.534. Now I could have used another trig identity to find the measure of angle B, but once again, it's often easier just to do some addition rather than typing an arc sine or an arc cosine into the problem. So Mr. G would like to take number 3.
You got it.
We're about done.
We are. All right, we're going to talk about an angle of elevation and angle of depression, and this is in your notes, so I will not read this to you, but I'll just paraphrase that if you have your eyes right here, and if you rotate your eyes down towards something on the floor, the angle of rotation, that's called the angle of depression. So if you're looking down, that's a depression angle. And if you're standing on the ground and you look up at the sun or look up at Mr. G because he's taller than you or look up wherever, the angle of rotation of looking up, that's called the angle of elevation. But I do want to ask or answer this question. What is significant about the angle of elevation and the angle of depression? And I'll give you just a second to think about that. These two angles right here, if you've seen this picture in geometry before, you should know that these two angles are equal. They are equal to each other. And do you know why that is? Do you remember from this picture the name of these two angles? That's right. They are alternate interior angles, and they are going to always be equal. So if you are given the angle of depression, as a bonus, that automatically means you're given an angle of elevation. What am I missing here? The word angles. Okay. Anyway, all right, so let's go work the last problem here, and we'll be done for this video. Flagpole cast a shadow that is a 60-foot shadow when the angle of elevation of the sun is 35 degrees. And I'm not going to grab this. I don't think I've got one that will draw the triangle the way it is here. So I'm just going to freehand this one. We'll look at that straight line. Look at those straight lines. Oh my goodness gracious. Okay, let's try this again. Don't even draw that. I'm going to do straight lines to make this happen. That was really pathetic. La la la. Yeah, I'm happy with this. I hope you're happy with this too. Okay, that better?
Yeah.
All right, cool. All right, so I've got a 60-foot shadow. Let's go green, just for the heck of it. A 60-foot shadow, and here's my flagpole. She's a high-flying flag. And this would be, shadows down here. So here's a 60-foot shadow, and the angle of elevation of the sun. Where does the angle of elevation go? Looky here, right here in this picture. This is the angle of elevation. It's 35 degrees. So I want to know the height of the flagpole. And Mr. Monahan, I am not going to finish this question. Here is what I'm going to ask our kiddos. I'm going to ask our kiddos to find this side over here, what trig function they would use to find this. And when they come into class tomorrow, I want them shouting from the rooftops or shouting from the top of the flagpole what trig function you would use to find this right here. So when you walk in class tomorrow, as you're walking in, I want you to yell which trig function you should use. Does that sound like fun?
That sounds like fun.
Yeah, we'll know which one of you watched the video too. So anyway, you guys have a good night. We'll see you tomorrow.